Hi, everybody. I just wanted to share a quick video to show you how to produce slope fields on your Ti-89 calculator. So I'm going to use the example here in the 1.3 packet, example number 2. This is in your packet. And we're going to just produce this direction field here and show you how to produce a particular solution curve to an initial value problem. So let's go over to the calculator on your calculator. All right, so the differential equation is dy dx equals 2x plus y. That is what we want to put on our calculator. The first thing we have to do is we have to go into the mode setting here. The default mode is function. So what you want to do is arrow over and then arrow down to number 6 differential equations, or just hit the number 6. But we need the mode to be differential equations mode. So at that point, we can then start setting up the differential equation. So to do that, we want to go into the y equals option here. So color coded here, the green button, F1 gets me to y equals. So it did not set up the mode. For some reason, let me do that again. 6, I didn't hit enter perhaps afterwards, but now in y equals, this should look a little bit different than what you're accustomed to in function mode. So basically in the calculator, we get to set up multiple differential equations if you want to. We don't have any use to use more than one at a time, so we're just going to be using the y1 settings here. Notice that we've got a t0 equals 0 setting here. So this is always 0 by default. This is basically for setting up an initial value. I don't really need that immediately, so just ignore that for the minute. The first thing we want to look at is this y1 prime. This is where we actually put in the differential equation. Notice that the dependent variable is called y1 on the calculator. And also, if we look down here at the command line, the independent variable is called t. So we have no choice but to use those variables on the calculator. I have to use y1 for the output and t for the input, not x and y. So our differential equation is y prime, so that is y1 prime, and that is going to be 2t plus y1. That is what I would need to put in here. 2t is on their calculator plus, and then I need to put in y1. So this is what we would need to enter onto our calculator. If you put 2x plus y here, it will not know what you're talking about. And that's really all I need to do here initially to get this set up. At that point, then I can just set up a window here. So let's go to green window setting. So you'll see again, t0 equals 0 again. That is the same setting as we saw in the other screen. This will be for setting up an initial value, which we don't need immediately. We'll use that here in a second. Otherwise, we have a T max setting and a T step setting. For now, I would say just leave these alone. The T step of 0.1 is appropriate for all our purposes, so I would just leave that alone and just not worry about those. What we have down here are the X min and X max settings. So this is for setting our window as we're accustomed to. Again, so I would probably, let's have it go from minus, actually, I think I had to go, very convenient to have it go from -5 to 5 in both directions. Again, X scale is just where the tick marks are on the axis, so every 1 is fine. And let's go from -5 to 5 in the Y direction. And then if I go down a little further, there are some other options here that might be useful, also not critical. N curves is a way to, if I put n curves equals 2, the calculator, when I hit graph, is going to graph my slope field and actually add in 2 arbitrary particular curves. So again, the calculator's choice, not our choice. You also have field res. That can be something to change. Field res 14 means there will be 14 columns of slope indicators on your screen. But let's just graph that and see what it looks like. So here is our field, our slope field, and there is one of the curves. There is another, again, arbitrarily chosen curve. You'll notice it starts basically graphing at the T0 and graphs them both forward, and then comes back and graphs them both backwards. But this is basically our slope field with a couple of arbitrary graphs drawn in. Again, what we're probably more interested in doing is picking our own initial condition and having the calculator graph a particular curve for us. So we can do that. If I go into my window setting, I can come down here to N curves, and I can set that back to 0, so it will not attempt to graph any curves for us. And then what I can do is, if I go to the y equals setting, I can put in my own initial value. So again, my first initial value, as on that study guide, the first one was 0, -2. So again, it's set for T0 to be equal to 0 by default, which is a good default number. Our other value here would be a -2, enter. So if I do that, I can then hit graph again, and it should graph. And then this time it's going to graph this particular solution that I told it to graph based on the initial conditions. So that graph there looks like a straight line. So that's actually part of the exercise in the study guide, is to determine what that straight line is. So I'll leave it to you to look at that further in the notes. Now let's suppose we want to change to a different initial value. I can go back to my y equals, and I can change it. So the other initial value asked for on the study guide was, I believe, 1, -3. So if I go up here and highlight, it's a little awkward. I can't just type over the top. If I hit 1, nothing happens. You have to hit enter, and then hit 1, and then hit enter again to change it. And then I come down to this -2, and I again have to hit enter. I have to put in -3 and enter. And just for kicks, let's see, if I go into my window settings, maybe I wasn't happy with that field resolution here. What if we change this to 20? So now we should see 20 columns of slope field. It's the same slope field, but we're just plotting extra slope field markers. But otherwise, it's the same. So let's graph and take a look. So now there are more columns of slope field markers. The field generally looks the same. And this is the particular solution that passes through 1, -3. So 1, -3 should be there somewhere. What did I put in? 1 is here, roughly. There's the markers. Here's 1, and here is -3. So down here is basically the initial condition we gave it. So we just graph that. So that's how we can do it. It's, again, fairly simple. Practice with it, and it is not too difficult. Thank you, guys.